Okay, in question 4, we don't have to read very far before we hit the words probability density function. So that tells us we're in the world of continuous random variables. Now there will nearly always be two continuous random variable questions. One will be the general case, and the other will be for the particular distribution, the rectangular distribution that you've got information about on page 11 of your formula book. Always, when you hit the first continuous random variable question, decide, is this the rectangular one, or is that the other one later in the paper, and look at the question later in the paper so you know which is which. Okay, I'm assuming you know what we're dealing with here. The first thing we've got to do is show the value of this missing k is 1 over b minus a. Now, values of unknown constants nearly always can be determined by thinking about the total probability, which of course is always 1. And in this particular case, I suggest a sketch graph and talking about the area on your sketch and using that to explain why k must have this particular value. But show that the answer is given, so you need to be convincing. B.E2 says, prove using integration that the expected value is this expression. So page 11, once again, of your formula book has got the general integration formula you need for expectations. So you need to integrate the correct thing between the correct limits and show that the value settles out to equal this. B, we've got a complete re-entry point here. So if you couldn't do the general theory in part A, we're now looking at a specific case of this distribution with given values of A and B, and the results we had from part A, you can put the values of A and B in so you know where you are. So writing down the value of the mean, mu of x, is only 1 mark, because you've effectively done the work for that already. Just need to put the A's and B's in. And the standard deviation, sigma of x, for 2 marks, okay, that 2 marks is relatively low. So therefore you're not going to be using the integration method, you're going to be using the shortcut on page 11. And you need to be careful about the word standard deviation, the fact that this is just sigma, so be careful with that. And then we need the probability that the random variable is less than this horrible looking thing here. But that's just a number. You know mu, you know sigma, calculate this, and you've got the probability of x being less than that value. On a sketch, consider the area you need, and once again you don't need integration, you can just work out that area directly by using the dimensions of the shape you've just shaded.